Hi guys, good to see you. Mr. Kane here.
Hi, Mrs. G. Mr. Kane, what's on the board now?
Oh, that's a good question. You know what this is? This is my parent-teacher conference list. Those are the parents I'm going to be seeing tonight.
Awesome. Parent-teacher night, my favorite night of the year.
Mine too. We get to stay till 8.
Oh boy.
All right, guys, we're going to do this quick because we want to get it done. So we're naming names and telling about what's going on here.
Okay.
By the way, guys, nomenclature.
Naming?
Yeah, nomen comes from the Latin word for name. Okay, so this is the system of naming for chemistry.
That sounds easy enough. Things
you got to be able to do by the end of this unit. You've got to be able to state and verify the octet rule. It's got something to do with 8, I know that. All right, got to know the names and formulas of the common ions.
And I just gave the list out today of the polyatomic ions.
Yep, those are on the back of your periodic table.
And for me, it was a separate handout.
All right. Write the formula of type 1, 2, and 3 compounds given the name. We want you to be able to write the name of type 1, 2, and 3 compounds.
So I'm assuming we're going to want our chemistry students to be able to write the formula of the compound given the name and write the name given the formula.
That's a good summary, Mrs.
Yeah?
G. Yep.
That sounds easy
good.
enough.
Name and write formulas for specific acids.
All right, specific acids.
So it sounds like there's naming rules for these two.
Okay.
But we're only going to give them a list for these.
All right, that sounds
Just
good.
memorize.
All
Okay,
right.
This you got to know how to work. All right, so here we go. Review of ions.
Ions. What's an ion? An ion is any atom that has a charge. Positive ions loses electrons, has a plus charge, called a cation. For example, lithium and beryllium. Lithium, I'll bet, oh, this could be hard. Lithium, I'll bet, is in family number 1.
I think so, yeah. I think that was trendy. That was a trendy idea, right? Because it forms a positive 1.
Left side of the table, loser. Beryllium is in family number 2. Left side of the table, loser, and it loses 2.
Lefty losers, huh?
Metalheads are losers to become positively charged, Mr. Kane. That's my little acronym.
Metalheads are losers.
Metalheads are losers to become positively charged.
Nice.
Negative ions gain electrons, has a negative charge, called an anion. For example, fluorine and oxygen ions. Fluorine gained 1 electron, oxygen gained 2.
Very good.
Ooh, polyatomics. Yep, there's that list again.
Yep, they can be complex. Take a look at the back of your periodic table or that separate handout.
Yep.
Common ions. So things like ammonium and phosphates.
There's the only cation, polyatomic cation on the list.
Yep.
The rest were all monatomic.
Ammonium. So the octet rule is pretty simple. Atoms and ions are more stable when they have 8 valence electrons. Okay, so that's 8 outer electrons. Sometimes this is called the noble gas configuration. Yep. All right. Atoms and ions can gain or lose electrons to achieve a noble gas configuration. Okay, so they can gain or lose. There are exceptions to this octet rule that include the transition metals. So we talked about how they were a little funky before.
And hydrogen and helium. Actually, beryllium too. So there are a few.
Yeah, there are a couple of exceptions, but for most atoms.
Mr. Kane, you want to know what I call the noble gas electron configuration for short?
What's that?
NGEC.
NGEC?
NGEC.
NGEC. It sounds like a meal on Star Trek.
GEC. NGEC. Noble gas electron configuration.
All right. So, for example, here we can see neon. You take a look at the drawing here. We have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons.
So it's already at the octet rule.
Already at the octet rule. Therefore, neon doesn't like to react because it doesn't like to gain or lose any electrons.
There's no room for it. There's only room for 8 people at the table, folks, and you already got the 8.
And here's argon. 1, 2, 3, 4, 5, 6, 7, and 8.
So another noble gas.
Yep, that's the second noble gas. The third noble gas happens to be krypton. And if you check it out, there are 8 here also.
And it's got 8.
2, 3, 4, 5, 6, 7, 8. I'm thinking that this is a high-level Sesame Street episode here where we count to 8. Brought to you by the number 8s. All right.
So anything that's not a noble gas would have less than 8?
Yeah, less than 8 electrons, because it would either want to gain a few electrons
or lose them.
or lose a few, depending on
Which side of the periodic table it's on. Or
Exactly.
which is easiest. Because wouldn't it be easier?
left sides are losers, right?
Yeah, metals are losers to become positively charged. Wouldn't it be easier for like magnesium to lose 2 than to gain 6?
Yeah, it seems easier to me to lose 2.
Yep.
Yeah.
Okay.
Or for oxygen to gain 2 rather than to lose 6.
All right.
Right. Yeah.
Left side
Loses,
then the right side gains. That makes sense. And they all try to look like the noble gases.
Yeah.
Or the negek.
Interesting. Mrs. G, haven't we done this before?
And this looks familiar to me. Wasn't it in the last unit on the very last video? The only thing I want the students to realize, Mr. Kane, is from the nitrogen group on, it's a gain of electrons.
So it's a gain from nitrogen
Over to the right,
halogens.
to the halogens.
Okay, and it's a loss up here.
And which comes right back to left side loses, right side gains.
But carbon's group is right in the middle.
Well, it's got 4. That's got 4 valence electrons, so it can go either way.
Okay, place for both teams.
Yeah, see, and nitrogen has 5 valence electrons. It's easier to gain 3 to make an 8.
And what about these guys at the end?
Those are the noble, inert, noble gases. They're happy with 8.
Oh, so that they don't form any charges.
They don't form charges. Nope, they do not form ions.
Reminds me of a joke that goes, the punchline goes, no charge.
No charge.
All right. So there's 3 different types of compounds. There's type 1s, which consists of metals and nonmetals.
Okay.
There's type 2s, which consist of metals that have multiple charges, which this phrase here just says to me transition metals, mostly.
Okay.
All right. I guess specifically just the ones that have multiple charges.
Right, not the zinc, cadmium, or
Silver. Right. Okay. And then there's and a nonmetal. Okay. And then the type 3s use nonmetals and nonmetals.
All right, so type 1, left side, right side.
Mm-hmm.
Type 2, left side, right side, but left side is your transition metal.
Actually, mostly center, right?
Center, right, yep.
Center and then right side.
And then type 3 is right, right.
Right side, right side.
Okay.
Okay, sounds easy. Let's go through some of these. Type 1 compounds.
Okay, name of the cation first. The cation is the positively charged thing.
Yeah.
Yep, all right. Anion last, but the anion has an "ide" ending. Okay.
All right, that's easy enough to understand.
Yeah, that sounds good.
All right.
Ooh, cation, always listed first.
So, magnesium.
So the cation is listed first, and then the oxygen is the nonmetal, but it gets an IDE ending. So I'd say oxygenide. No,
Oxygenide, like that?
That sounds silly.
Yeah, that doesn't sound easy to say either. I don't want to say
Oxygenide,
that.
yeah,
Say that 10
it's a
times quickly. No,
How about oxide?
Okay.
Magnesium oxide?
OX.
IDE? That sounds good.
Let's take out the Y, because otherwise it's like oxide,
Yeah,
which would be hard to
yeah,
say.
that's
So,
weird.
so you've actually got to cut off part of the name?
Uh-huh.
Okay. Is there any rhyme or reason to that, or do you just have to kind of sound it out?
Just kind of sound it out.
Yeah, okay. So magnesium oxide and magnesium oxide.
we were
check
right.
that out. All right, very good.
Awesome.
Ooh, hey, they come together.
Cool.
That's nice.
Two words.
It's 2 separate words, not 1 word. Here we go.
Oh, what is that? Let's see.
I don't remember. Is that sulfur?
No,
No, that's not sulfur.
that is a metal and a nonmetal.
Yep.
Sodium comes from family number 1, so it's a +1 charge. Fluoride comes from family number 7, so it's a -1 charge. It's binary. It's a type
Binary?
1.
What does binary mean?
Ooh, I don't know. What is a bicycle?
Binary, bicycle.
Is it possible it's 2 atoms bonded together?
It looks kind of like it's binary. It's 2 different elements, right?
Yeah,
I got
1,
sodium
2.
and fluorine.
Yeah.
Okay, so it's binary. Okay.
So I'm going to assume, based on the rules, sodium, and then fluorine with an IDE ending would be fluoride.
It looks like sodium fluoride, yeah.
Okay.
Okay. Looks to me like another binary here, Mrs. G, right?
Yep.
I mean, we got the element zinc and the
Zinc
element
and
chlorine.
chloride.
So binary talks about elements, not atoms?
Binary talks about elements, not atoms.
Okay, because there's actually 1 zinc and 2 chlorines, right? 1 zinc, 2 chlorines, so that's
Yep.
a total of 3 atoms, but this is still binary because it talks about
Two different types bonded
elements. Okay. All right, so zinc and chlorine would make zinc
together.
chloride.
Chloride, yep.
Yeah.
How come the chlorine has a 2 subscript, Mr. Kane?
Well, that's because that this 1 zinc needs 2 chlorines.
Oh, because zinc has a 1 plus charge, and since compounds are 0,
Uh-huh.
you need 2 negative 1s to add up with the positive 2 from the zinc to make 0. Is that right? Sound right?
That sounds about right, because I've got this
Yeah.
positive 2 charge on my zinc,
And a negative 1 on the chloride.
and I've got only negative
Okay.
1 on the chloride, so I need 2 of these negative ones.
So we're going to have to do a little algebra here, a little math here, aren't we?
It's barely algebra, I mean,
Yeah.
it's arithmetic.
Just a little mathematics.
This looks like aluminum sulfide.
Okay.
Yeah. And the reason why there's 2 aluminums and 3 sulfurs is because aluminum has a
1
3
aluminum has
plus
a 3
charge.
plus. Yeah.
So that's a total of 6 positive charges, right?
Yep.
And then this has a 2 minus charge
And
for a
that's
total of
negative 6.
6 negatives.
Plus 6 minus 6, that's a 0, which compounds are all zeroed.
Okay.
No charge on compounds.
So if I'm looking at potassium, I know potassium's in the first group, so it's 1 plus.
And there's 3 of them, so nitrogen is going to be 3 minus, isn't
Nitrogen is 3 minus, yeah. So
I can
that
do math.
would be potassium nitride.
it? Yep.
All right. And then if I'm doing the math here, ooh, there's only 1 aluminum. I guess I should write that in.
It's usually understood, but
3
you could
plus.
if you want.
And this is 1 plus, because 1 times 3 gives me 3 positives. Oh, I messed up.
Oops. One of them's got to be negative. You'll always have
Yeah.
a positive and a negative.
So we'll do that. There
That
we
would be a
go.
plus 6.
That'd be plus 6.
That would work.
not be right.
That's not going to work.
All right, so I've got a negative 1 times 3, which is going to give me the negative 3 charge.
Right.
The 3 negative charge. And then this is going to be my 3 positive, 3 times 1.
Okay.
And so we'll call that aluminum chloride.
Yep.
And then finally we have germanium iodide. Yeah.
So first name is proper, right off the periodic table. Second name comes from the periodic table, but with an IDE ending.
Yeah, so you have to take off part of the name.
And it's relatively intuitive with sounding, right?
Yeah, you just got to make it easy to say.
All right.